and WD is 5 kilonewton, and the weight of the bridge is 100 kilonewton, and my friction force would be 1 kilonewton. So first we're going to draw the free body diagram. As you can see in the picture, I have FAY and FAX on the left side and FBY on the right side, and I have the car and the weight of the bridge, the weight of the car, the front and the back, and the friction force and their distance from the origin. So I'm going to assume that at point A is going to be my origin. Now write the governing equations. This is always good to do so you don't forget which tools you have available to you. It also makes it easier to review your work. Since it is a 2D problem, we can't have out of plane displacement or rotation that would have us leave with the plane of the paper. So we are left with the following three equations, which is the total force in the x direction equals to 0, and y direction equals to 0, and also the moment in the z direction equals to 0. Now you can see why it was important to not have a reaction force in the x direction at B. We only have three equations, so we can only handle three unknowns with this method. Step 3 is to start applying the equations. There is no right answer for which to use first, but sometimes picking one equation first will require less algebra. Experience will teach you how to pick the best method of attack. Now here, the x direction force balance looks easy, so let's start with that. Total force in my x direction, it has to be equal to 0, as I just mentioned it before. There are only two forces in the x direction. One is the friction force of the car, and one is the force at A origin. Therefore, the force AX is equals to the friction force of the car, which is equals to 1 kilonewton. Now, so the reaction force on the bridge is equal to the force of the car accelerating. Since the value is positive, we assume that correct direction for the force. Now, let's find the moment about point A. We are doing this because, based on experience, we can see that this equation will have only one variable, while the y direction force will have two variables. We should then start with the moment equation before moving to the force. We could solve it in the other order, but there would be more algebra required. Now let's see. Net moment at origin A is equals to 20 of force in the y direction at B minus 5 weight of the car. So note that these are the distances. So as you know, the formula for moment is force times the distance. So the distance of the force at origin B is 20, so I multiply it by force, minus 5 meter, which is the distance of the front of the car to the origin A, and we assume it negative because it's downward, minus 7 meter times the weight of the back of the car, minus 10 meter, the distance to the weight of the middle of the weight of the bridge, which is equals to 0. And by rearranging here, I can understand that the force at origin B in the y direction would be 54.25 kilonewton. So I have my total force in the x direction. I have the total moment at origin A, which was equals to 0, and from there I found out that the total force in y direction origin B is equals to 54.25. Now we can use our final equation, which is the total force at y direction equals to 0. Here I have the weight of the car WC, WD, and the weight of the bridge W, and the force at the y direction origin B. The only unknown here is the force at y direction origin A. So by rearranging, I can easily find it, and it is 60.75 kilonewton. Now, as you can see, the answer makes sense, because you would expect the force on the left to be larger than the force on the right. Now let's go back to the diving board. Keeping the same assumptions for this problem, let's say the weight is 500 Newton. So step 1 would be to draw the free body diagram, as you can see in the picture. Then write the governing equations. Net Fx equals to 0, net Fy equals to 0, and net moment at z direction equals to 0. Then we're gonna start applying them. So first we're gonna start with the net Fx, and as you can see here, net Fx, the only one is Fb in the x direction, so therefore it's equals to 0. Then I'm gonna start with the net Fy, and here I have force at the B in the y direction minus the weight of the board, which is equals to 0. Therefore these two are equal, and they're equal to the weight of the board, which is 500 Newton. And let's take the moment around B. So the total moment at point B would be its distance to the origin times its weight minus moment at point B, which is equals to 0. Therefore from here I can find the moment at point B to be 300 Newton meter. We have now found the reaction forces at the base of the diving board and are now ready to look at how to attach the board. So in conclusion, while there are many applications and special cases, the important fact is that with the basic understanding of forces and moments and the ability to draw a good free body diagram, many important questions can be answered. Don't forget, drawing a good free body diagram is really important. It shows you what you have and what you need to find. Using the concept of summation of the forces and moments is one of the most basic and useful ideas in engineering. So all the time have your equations written and just look at it, and easily you can see which one you can find first and which one you can find second, and at the end you can find all the forces that you need. Through understanding of the examples presented here will allow you to learn a lot about many practical problems. I hope this was useful. Thank you so much.